hopefully. All right, so I guess we can start. Did everyone who needed coffee get back? If you didn't get back, just raise your hand. Okay, so my name is David Mertens. For those of you who weren't here at 9 o'clock, I gave the introduction to PDL. And I'm now going to introduce a plotting library that I've written for PDL that's based upon the Prima toolkit. And just a couple minutes before, we were discussing this. And the reason that I wrote this is because there's no obvious plotting library for PDL, which is irritating. MATLAB has an obvious plotting library. NumPy has an obvious plotting library, which it's Python. There should be one obvious way to do it, right? I don't actually know that Ruby has something like PDL or NumPy, but I'm sure they've got a plotting. Actually, Perl has a lot of plotting libraries, right? But there aren't PDL-centric plotting libraries that are obvious. pgplot is the standard, and it's what's used frequently in the PDL book and elsewhere in the docs. And Maggie uses pgplot. It's based on Fortran. So if you don't have any problems with Fortran, you're pretty much good to go. I actually like Fortran, but I feel offended that I need to have a Fortran compiler for my Perl stuff. Perl is based on C. We should have things on C. Anyway, so that's one reason that I don't use pgplot. plplot is a C library, and it has some pretty good bindings for PDL, some pretty substantial, like deep bindings. But sometimes it lags behind plplot. And another issue that I have is that plplot has if you make a histogram, you can't, plplot will bin it for you, and it won't tell you the maximum. It'll just plot it. And so if I wanted to tweak that plot, if I wanted to, say, change the maximum height based upon, I don't know what it is. And so there's things that you cannot learn about your data when you're using these C bindings. PDL graphics GNU plot is pretty new. The plplot showed up, I want to say, 5 years ago, 8 years ago. pgplot was 15 years ago or whenever they started. GNU plot is new. It's within the last, I want to say, year and a half. It sends all of the data through a pipe to a GNU plot instance. And so that is actually very flexible, but it's slow if you're plotting large data sets. And there's also kind of I'm pretty sure it's one way, so it's very hard to get information. I could be wrong. I shouldn't say it's one way. I'm not sure, but nonetheless, it is kind of tricky. I know there have been some issues getting it to work properly on Windows. I don't know if they've been sorted out. There's also 3D plotting using PDL graphics Tri, T-R-I, capital T-R-I, capital D, Tri-D. That's a totally different area that I'm not worried about. This is all 2D plotting that I'm focused on. But there's none of these work well. I can't say someone, go to CPAN, download this, because none of these are purely installable from CPAN. They all use external things. So I wrote this thing. It's based on Prima. Prima is like TK, except it was written specifically for Perl, and it's a full GUI toolkit. It was written because TK did not support OS2. OS2 like IBM OS2, not Mac. And so they were able to build this. The internals are gorgeous. I would like to take this and generalize it so we can actually have like object-oriented C programming with Perl. Anyway, whatever. So it was pretty easy for me to take these internals and then wrap PDL-PP around them so that I could draw 1,000 lines on a widget like that, because PDL does all this C looping very quickly. Once I had that, then I was able to create this whole plotting library, which is a widget. So you can create an application where you can, say, adjust a slider and it changes your plot interactively. I'll just show you some of these things. So let's keep going. I should make clear, Prima was not made by me. That was made by Dmitry Karazik, I think that's how you pronounce his name, and other people at the Protein Laboratory in Copenhagen. He now maintains it. They developed it in the early 2000s. PDL drawing Prima, that's the thing that is just the straight hooks around the drawing functions. I wrote that, and I'm not going to talk about that, but it is utilized in the plotting library. What I'm talking about is this, PDL graphics Prima. I think that's all I wanted to say about that. So this is supposed to be one line, but it didn't fit. So all I'm going to talk about is PDL Graphics Prima Simple, which is basically an interface to just make a darn plot. If you had to always make a widget and make an actual GUI application and embed the widget, it's a pain, right? So this kind of simplifies that, so you can just look at your data and see what's going on. This presentation program is actually written in Prima, by the way. So I was able to put hooks into it. So here's a plot. Let's see what this does. This is a full script. Top to bottom, you could run this. You could just copy paste it into test.pl and run it. So it needs PDL, and it needs to load this PDL Graphics Prima Simple. And then we create some X data, some Y data, and we plot it. Now, the cool thing about this plot is that you can like move it around, and you can zoom in and zoom out. You can zoom in on a region by right-clicking and dragging. The zooming in and out is a scroll wheel. If you decide that you're tired of playing around, you can auto-scale it. Notice I didn't specify the min or the max X or Y. It automatically computes it. And in fact, the minimum data here is -1, but it goes slightly past it because it gives it enough room so that these diamonds fit. So any feature that, I'm very proud of that because it's actually not trivial to figure out the optimal bounds so that everything fits. But the whole point was, you give it data, it does the right thing. So what does a typical plot command involve? This is actually identical to what you see in a constructor for the widget. So this is like if you just start with plotting data and then you want to graduate to actually creating an application that uses the widget, the form will be the same. So data sets begin with a dash, whereas options, so if you want to specify details for the x-axis, that does not have a dash. And now the reason, so TK apparently all options are with a dash. In Prima they don't do that. So in Prima all the options are without a dash, and I had to find a way to differentiate data sets. You can use whatever name you want for your data. Now, there's different kinds of data, right? There's pairwise data, like the one that I've already shown. But suppose that I want to plot like a matrix, like an image, right? That's actually a grid. And so then there are different ways to render grids than from pairs. And so you have to think about, okay, is this data like a set? Do I want to look at a distribution? Or do I want to look at a time series? Or do I want to look at a correlation matrix or whatever? And so there are different data sets, and those will have different plotting things. And we'll get into those in a few slides. But you have to think about it up front. Okay, what kind of data do I have? That will affect what you choose here and then how you can actually have it drawn. Okay. So this is, I want to show in here the idea that once you've chosen your data set, so in this case it's pairwise data, you can take all the different plot types that are available for that and just compose them. Now it turns out that for setwise data, there's one. It's cumulative distribution function. There's only one thing you can do. And with grids, you can only look at an image. But with pairwise, you can generate error bars. You can plot, say, squares. And if I compose them, it combines both the error bars and the squares. I can do histograms, in which case it draws the histograms, the squares, and the error bars. Right? And you can just basically do all these different ways to render the data that you might want to do, to visualize it however you see fit. All of these different things may or may not take options. So error bars, for example, I specified the Y errors. But I think you can specify, I'm going off script. Damn it. Okay, but there are ways to specify that only the upper error bars are a certain value and then the lower error bars are something else. All right, I'm not going to go off script anymore. Is that right? Yes, good. All right, so but the whole point is, if you just want to have a histogram to show a distribution, but you know that there are errors on your distribution, it's very easy to compose that. I also show that, for example, the axes are the things that know about their labels. So if I want to say that effort goes as the square root of payoff, the other way around, payoff goes as the square root of effort, then I can set these labels by specifying them in here. All of the drawing operations accept properties. So when you draw a line, you can specify the line thickness or the line pattern or colors. And then the way that the plotting library is written, you can specify the colors for a data set. And then, perhaps within a particular plot type, so if I want the histograms themselves to have a different color scheme, then I can specify that specifically. So in this case, the lines, so the error bars are going to have generic colors. The histograms are going to have generic colors. But the lines are going to have something else. They're going to have line colors. And it sort of like inherits the color unless you specifically override it. So an example of where this is useful, well, I'm sorry, this is not useful, but where it's illustrated, I create a series of colors based upon a rainbow palette for X. So basically, the colors represent going upward linearly from, let's see, what uses rainbow? The error bars use rainbow. So in this case, it's red to orange, yellow, green, blue, purple. That is up for the rainbow palette. And the reverse rainbow palette is just the opposite, where I use the minus sign for X. And so the default color is the reverse rainbow. That's what we have with the squares, whereas I override it for the error bars. And so something that is neat about all of these is I could specifically, each one of these colors is specific to each point. This is doing what's called PDL threading, where I can specify any particular element of rainbow to be a specific value, and then when I say, okay, draw these points with this palette, it does a C loop, runs through, extracts each color for each point, and does it for me. So I might have a consistent, I could have, say, all these be black and one of them be red. And rather than doing two plots or doing two data sets in order to plot it, I just change one value in the color, in the color property. And it does PDL threading for me to solve that problem. Now, if you're trying to combine data sets, they go in alphabetical order. So this is kind of a cool plot of the cosine of x times y. But there's supposed to be this curve, this function, but you don't see it, right? In fact, as you can see right here, it's supposed to be red. You don't see any red on this plot. And the reason, here, it's up here. It's over here. But the reason you don't see it is because the data sets are plotted in alphabetical order. So what I can do is I can actually specify, plot the data first, and then plot the curve. And then you can see that it has this nice, it plots it on top, the order that I wanted it. This is supposed to predict where this function was going to be maximized based upon the data. So in other words, you can control the order in which things are drawn. The way you control the order for plot types, and those were, histograms, squares, error bars, those are in the order you specify, because that's in an array, an anonymous array. But with the named data sets, they have to go by ASCII-betical order. All right, so let me take a brief break to the super simple interface. This is handy if you want to do one-liners. You can actually create a one-liner for this function plot, and then you can look at the cosine function. But there are lots of different sorts of okay, I just want to do a scatter plot, and I don't want to, hold on a second. I don't want to have to specify all this cruft. I just want to give you x and y, and I want to see the plot. And so to do that, you would use these super simple functions. So funcplot will take a function reference and plot it. You can actually specify. So here's another example where this is sine of 1 over x. So as you approach 0, it kind of goes crazy. So, yeah. So you could even specify that you want it to use 10,000 points. There we go. And I think that's the problem. Yeah. So then we'll have a little bit more detail and resolution when we approach to see what's going on. But again, this is just hey, show me the data. Let's not go into the details of configuring. There's also matrix plot, IMAG plot, although I don't show that here. And then there are all these different things for doing pairwise data. So this is a line plot. We can look at hist plot real fast. Circle plot just draws circles, triangles, squares. Are you seeing a pattern emerge? So the reason why I show you all this is because all of these are just like, hey, draw a shape at my x and y points. And that brings me to this drawing type, symbols. And I'm running really low on time, so I'll see what I can do. But what you can do is you can say, okay, I want to draw this point with 5, like at this xy, I want you to draw a shape with 5 points filled, and I want you to draw to every other thing. That's what the skip is. So let's see what this sort of starts to look like. This is symbols, so you can split the number of points, whether it's filled, how it's skipped, etc. Oops. And so here, this will draw where the x value is the number of points. So it goes 0, that's degenerate, it's a circle. 1 is a circle. 2 is a line. 3 is a triangle. 4 is a square. 5 is a point, right? Etc. You can specify whether it's filled or not. Now, something that's really neat is skip. So take a look at this 5-pointed piece. And when you specify a skip, you know, we're going to cut this down so it goes to 10. And auto scale. There we go. So what it does when you skip 2, so when you skip 1, it goes from here to here to here to here to here to here. When you skip 2, it goes not to this point but to this point. And then it goes not to this point but to this point. And so you can create this whole menagerie of shapes to differentiate your data. And you can do it algorithmically. You don't have to name everything. You can name everything, which is kind of what I showed already, but you don't have to. In this case, I'm showing you the order of the drawing matters, right? So this draws these circles, and then on top of it, it draws triangles. Is anyone here from Texas? There, I was shout out. You know, no need to hate. All right, I'm not. I'm from Missouri. All right, so there are lots of ways. I mean, you can still name them if you want everything to be drawn in triangles. The default for pairwise data is diamonds. But so these are all the different ways that you can actually specify how you want things to be drawn. I've already shown you this example with color. You can use palettes to create piddles of color. Prima has its own color thing, so you have to create a piddle of Prima colors, and that's what these do. Maggie Jean, who's sitting right here, has done some amazing work with different color spaces. Right now, there's HSV, hue saturation value, is kind of built into this library. But she's done a lot of other color spaces, and one of the things that I do after I learn how to use PDL stats, or after I start playing with it now that I've learned how to use it, is to learn how to use color space and how to incorporate that into this library. So you can specify a constant intensity range using one of these other better, I don't know, what, yeah, like HSL is a much better sort of rendering or representation of color. But there are lots of different palettes that you can use to kind of automatically do this, and there will certainly be more. This is a very new library and young, and lots of room for growth. If you think this is cool, the most important thing I can use right now is enthusiasm. So if you can send me emails and be like, this is great, I need feature X, that is like the second best thing you can do to help. The best thing would be to actually contribute code, right? But the second best thing would be enthusiasm. And so there are lots of things I want to add, like you can't add text annotations. I can't say this is figure A and this is figure B, right? It's easy to do in Prima. I just need to do it. I want to create Cairo bindings around Prima drawable, so then I can create SVG, PDF, PostScript, beautiful anti-aliased plots, because I can't do that. I can create ping raster plots with Prima, not on Mac. It doesn't work on Mac, but it works on Windows and Linux. You can actually right-click and save an image as a raster format. If I had Cairo, it'd be awesome. The guy right there, Joel, he's working on Alien Base. Once that's in place, I can get Cairo under Alien, and then I can actually say, go install this on CPAN, and it will just install, and it'll be wonderful. So anyway, I also want a pony. That's the last thing. All right. That's probably a really old joke, isn't it? Okay. These are other things I work on. These are other things I like to think I'm working on, and this is what I actually am paid to work on. And that's what keeps me busy. That's what I have to say. Any questions? Cool. Well, that's all my time, so thanks. Ooh.
Like a lib IDF idea.
Oh, okay. That'd be cool. So, yeah, he said he had some code about writing PNG files. Actually, that may be the easier one, because I think PDL already has PNG output. But we should talk. Yeah, right.
Where is your code?
Oh, yeah, all this is on GitHub in various stages of completion. Yeah, some of it's on CPAN. Oh, sorry, yes. So the most recent stuff is on GitHub. I think I cut a release on March 15th that's on CPAN, and there have been a couple of little things that I've corrected, but nothing major since March 15th on CPAN. So all of it should work on CPAN. Yeah.
So mostly working in the rep or it's like text pad type thing, right? If you do like bin maps.
So yeah, so the question was, so all of this talk is done in this Prima repo that I wrote, but the question was, can you do other things in like Vim or whatever? So you can actually, if you go to PDL and you say use PDL graphics Prima simple, and then X's are sequence spelling 10 and Y's are X's. Oh, let's just do it. Line plot X's and sign of X's, and it should just, there you go. So you should be able to do this in Vim or Emacs or anything that can start Perl and load access modules should be able to run this, and then you could do plots from wherever, and it loads up this Prima window. Yep. And on Linux and on Mac, it's actually threaded, so I can go back and make another plot. And then I actually have both available and mess around, or because it does proper forking, but it doesn't work so prettily on Windows. But I digress. Okay, wasn't there another question? Yeah. Okay, yeah, so there's this nice little thing where on the right click it said PostScript, but that was an experiment. And Prima actually has a printer-like interface, but all of the PostScript things it creates are 8.5 by 11s. And it doesn't do the fonts quite right. So you can, but it's not going to be right, which is why I want Cairo. If I can get Cairo bindings, then the PostScript will be exactly what I want it to be. Yeah. But yeah, I'll need to do that for academic stuff.
It looks like a three-dimensional data set that I wanted to represent the z-axis and the z-value, like the size of the thing.
You could do that. So symbols. Symbols is the only way. Symbols and like blobs are the two where you can specify. Oh, I guess I have to stop, don't I? All right. Yep, that makes sense. All right, well, thank you very much.